Near-death experiences are vivid personal events reported by some people after surviving life-threatening medical emergencies. Researchers discovered surprisingly similar patterns appearing across cultures, ages, religions, and healthcare systems around the world. The clarity was unlike anything I had ever experienced. Time itself seemed to stop, and there was an overwhelming sense of peace and awareness. Scientists began asking whether these experiences reveal hidden properties of the brain or conscious awareness itself. Modern instruments measure electrical brain activity, yet conscious experience itself remains impossible to observe directly today. During cardiac arrest, scientists observed that certain brain activity may briefly continue despite absent heartbeat and circulation. Researchers remain cautious because electrical activity alone cannot demonstrate whether conscious awareness truly continues after collapse. Current scientific evidence raises fascinating questions, while leaving many fundamental mysteries about consciousness still unresolved today. To understand these mysteries, scientists next examined the world's largest studies of near-death experiences ever conducted. The analysis suggests a consistent pattern.
Indeed, look at the neural activity here.
Global data confirms the hypothesis. Some memories appeared surprisingly detailed, encouraging researchers to investigate how awareness might arise during extreme conditions. Current evidence suggests certain neural processes may continue briefly before irreversible biological damage permanently develops. Researchers continue exploring whether these remaining neural activities contribute directly to conscious experiences reported after recovery. Although intriguing, existing studies remain insufficient to establish definitive scientific conclusions about conscious awareness after cardiac arrest. Large collaborative projects continue improving data quality through standardized interviews, monitoring technologies, and long-term. These discoveries challenge scientists to reconsider how consciousness emerges, changes, and possibly fades during critical medical emergencies. The next question became whether near-death experiences reveal important clues about consciousness itself, rather than death alone. Understanding near-death experiences requires first understanding how consciousness normally emerges from billions of interconnected neurons. Every conscious thought depends upon continuous communication between widespread neural networks operating throughout the living human brain. No single brain region produces consciousness, because awareness emerges through coordinated activity across many interconnected systems. When circulation suddenly stops, these communication networks gradually lose coordination, instead of shutting down instantly everywhere. Reduced oxygen weakens neural communication, potentially changing perception, memory formation, and the experience of scientists believe consciousness may fade gradually as synchronized electrical patterns become increasingly unstable throughout the cerebral cortex. Exactly when awareness disappears remains controversial because no instrument can directly measure subjective conscious experience today. Scientists can measure brain activity precisely, yet awareness itself remains hidden behind every measurable biological process. Each new discovery improves scientific understanding, while revealing even deeper questions about the true nature of consciousness. Scientists next explored which biological mechanisms might generate near-death experiences during moments of extreme physiological stress. Researchers proposed several biological mechanisms that may contribute to near-death experiences without invoking supernatural explanations. One leading hypothesis suggests oxygen deprivation temporarily alters neural communication, perception, memory, and temporary bursts of coordinated neural activity may produce unusually vivid perceptions during the brain's critical physiological transition.
Some experimental studies observed short-lived increases in organized brain activity following severe circulatory interruption in animals.
Scientists continue investigating whether these electrical patterns correspond directly to subjective conscious experience reported after recovery. Another hypothesis proposes REM sleep mechanisms briefly intrude into consciousness during extreme physiological stress and trauma. This unusual overlap might explain dreamlike imagery, vivid emotions, and distorted time perception reported by survivors. Every proposed mechanism explains certain observations, yet none completely accounts for every documented near-death experience worldwide. Current evidence indicates multiple biological processes likely interact together, rather than one isolated mechanism. Despite remarkable progress, scientists still face profound questions that existing technology cannot fully answer about consciousness. Despite significant progress, scientists still cannot precisely identify the exact moment conscious awareness permanently disappears. Modern technology accurately records brain activity, yet subjective awareness remains impossible to measure directly with current instruments. Different investigations sometimes reach conflicting conclusions because methodologies, patient populations, and monitoring techniques vary considerably. Memories reported after recovery may not always reveal precisely when those experiences originally occurred during medical emergencies. Successful resuscitation demonstrates remarkable brain resilience, although recovery depends greatly upon oxygen deprivation and treatment timing. Many experts agree consciousness remains one of biology's greatest unsolved scientific mysteries. Despite history repeatedly shows difficult scientific questions often require entirely new technologies before meaningful answers become possible. Understanding consciousness may ultimately transform medicine, neuroscience, psychology, and humanity's understanding of the living mind itself. Every new discovery answers important questions while revealing even deeper mysteries waiting beyond today's scientific knowledge. One final question remains. What conclusions can science confidently draw about consciousness from near-death experiences today? After decades of investigation, science has revealed important clues, yet consciousness remains one of humanity's greatest mysteries. Current evidence suggests consciousness depends upon complex interactions between countless neural networks rather than isolated brain regions. Near-death experiences may reveal how the brain responds during extreme physiological stress instead of ordinary conscious function. Whether these experiences originate entirely within the brain remains an active question under scientific investigation worldwide. Throughout every stage of life, consciousness shapes perception, memory, identity, and every meaningful human experience we possess. Future technologies may reveal aspects of conscious awareness that today's instruments remain unable to observe directly. History repeatedly demonstrates that unanswered scientific questions often inspire humanity's greatest discoveries. Understanding consciousness may ultimately transform medicine, neuroscience, philosophy, and our understanding of what it means to exist. Current scientific evidence neither confirms nor excludes extraordinary interpretations, emphasizing the importance of do near-death experiences reveal hidden truths about consciousness, or simply the remarkable abilities of the human brain under extreme conditions?